Nice to meet you. I'm Khatar Chokhtai and you're watching my YouTube channel, School of Advanced Chemistry. I am going to explain more difficult question in 9701 May-June 2024 1-2 variant. Let's get started. Basically, there are five questions found to be more difficult. Question number 4, question number 16, question number 22, question number 26, and question number 40. Let's solve these questions. Question number 4, first of all. In which pairs are both species free radicals? 1, 2, 3, and 4. Four options are lying over here. I'm going to write their electronic configuration to diagnose the nature of their free radical. Normal atom, normal Cl atom, and normal oxygen atom, they both are basically free radical. For example, in case of oxygen, it is having 8 electron. So 1s2, 2s2, and 2p4. I'm going to split p orbital, 2px, 2py, and 2pz. So 1 electron over here, 1 over here, 1 over here, and the fourth one is going to be paired up. So here are 2 unpaired electron. So this oxygen atom is said to be free radical. Come towards Cl, chlorine, that is having 17 electron, 1s2, 2s2, 2p6, 3s2, and 3p4. Once again, this p is having 4 electron. Three p5. So I'm going to split this p once again. 3px, 3py, and 3pz. 1 electron over here, 1 over here, 1 over here, 3. Here is a fourth, here is a fifth, and here is 1 unpaired electron. So yes, first option is the correct option. Come towards Cl negative ion. If Cl negative ion is over here, it means it has gained 1 electron. If it has gained 1 electron, then this will be 3pz, for example, that has been paired up. So there is no more unpaired electron lying over here in Cl. So it is not free radical. Free radical is a species in which any atom that is having at least 1 unpaired electron, 1 or more unpaired electron, so that species is said to be free radical. So it is not free radical, same as the case with oxygen. It is having 2 more electron, and here will be the pairing of the new electron, and now there is no any single electron, no unpaired electron in oxygen. So second option is the incorrect option. Come towards Cl, that is already you have been seen that that this one, this 3pz is having 1 electron, unpaired electron. So it is a free radical. What about O1 negative? In case of O1 negative, the second P, let's suppose Py will be paired up. And again, yet 2pz is still unpaired. That is having only 1 electron. So yes, they both are said to be free radical. Cl1 positive. If I'm going to remove 1 electron from the Cl, then it will be removed from the paired orbital, either from 3px or 3py. So only 1 electron. It will not be taken from the unpaired orbital. It will be taken from the paired orbital. So now there are 2 unpaired electrons. Still, it is a free radical. O2 positive. So 1 electron will be taken over here. 1 electron will be taken from any other one, 2pz, 2px, 2py. Still, there are 2 electrons, 2 unpaired electrons are remaining, even O2 positive ion. So yes, it is also a free radical. So 1, 3, and 4. A is the correct option. Question number 16. Which statement is correct? A. Aluminium chloride has a giant ionic lattice of Al3 positive ion and Cl negative ion. No. Finally, aluminium chloride AlCl3 is a covalent molecule, is a covalent compound. So it is incorrect. B. Sodium chloride dissolve in water forming hydrogen chloride and sodium hydroxide. No. Whenever the sodium chloride or any soluble salt that is dissolved in water, normal salt, it is going to make sodium positive ion aqueous and Cl negative ion aqueous, not the ACl and NaOH. So it's wrong. The strong C part, the strong covalent bonds in silicon chloride prevent it from reacting with water. No, silicon chloride readily react with the water. It become hydrolyzed. I mean, it is going to react chemically with water, and there is a formation of HCl and SiO2. So this is also incorrect description. So the D, the last one, will be obviously correct. When phosphorus 5 chloride is added to the water, the resulting solution conduct electricity. Yes, it is true, because there is a formation of H positive ion, PO4 3 negative ion. Same is the case, H positive ion and Cl negative ion. So these ions are mobile ion present in that solution. That's why it is going to conduct electricity, and D is the correct option. Next question is question number 22. 22, which statement describes a property of ammonium ion? And this is the ammonium ion, NH4, one is the dative bond, NH4 positive charge, ammonium ion. Aqueous ammonium ion is a weak Bronsted Lowry base. No, this ammonium ion is having no longer or no any lone pair. There is no more lone pair on this nitrogen atom, so it cannot act as a base. It cannot accept H positive ion, so it cannot act as a base. Aqueous ammonium sulfate reacts with dilute hydrochloric acid to make ammonia gas. Ammonium compounds react with alkalis, not with the acid, to make ammonia gas. So it is essential to react ammonium sulfate or ammonium compound with the bases or alkalis. Again, it is incorrect. An ammonium ion has a pyramidal shape with NHN bond angle 107 degree. Overall, this covalent bond is pretty similar, and that is supposed to be the simple covalent bond as well. I mean, this dative bond, this coordinate bond is similar as that of the other covalent bond. So overall, 4 pairs are surrounding this nitrogen atom, and it is like AP4 molecule, and the bond angle is equal to 109.5 degree, and its shape is tetrahedral. Its shape is not the pyramidal. So once again, there is only one option left. D, it will be the correct, obviously. The 4 NH covalent bond in ammonium ion are identical. Yes, it is true. As far as their bond energy is concerned, as far as their nature of reaction is concerned, they are identical. It's true. So D is the correct option. Question number 26. Z is gaseous hydrocarbon which has a density 3.5 into 10 raised to power minus 3 gram per centimeter cube under room condition. Z react with excess hot concentrated acidified KMnO4. Only one type of carboxylic acid is formed in this reaction. This question is about the oxidation of alkene from organic section basically, and here from this hint or from this indication, if there is formation of only one type of carboxylic acid, then mean this hydrocarbon, gaseous hydrocarbon, is having carbon-carbon double bond at the middle of the molecule. So next thing is 1 centimeter cube is having this mass. So I can change this centimeter cube into mole, and with the help of this gram, I can find its MR. So I know that 24,000 centimeter cube is equal to 1 mole, and 1 centimeter cube of a gas is equal to 1 over 24,000 mole. That is the mole of that hydrocarbon. Now next thing is we are having its mass as well. Now we have calculated its mole. So we know that mole is equal to mass over mr. In other words, mr is equal to mass over mole. So mass is equal to 3.5 into 10 raised to power minus 3 divided by, that is 1 over 24,000. So final answer of mr is equal to 84 in this case. So it means that there is an alkene that is a symmetrical alkene, that is having middle bond, double bond, at the middle, and its mass is equal to 86. And as it said that it's a hydrocarbon, and from this hint that we are going to add acidified KMnO4, we know that it is an alkene hydrocarbon. So CnH2n is a general formula of alkene that is equal to 84, and I can write with respect to masses 12 into n plus 1 into 2n is equal to 84, and 14n is equal to 84, and n is equal to 84 over 14. That is equal to 6. So n is equal to 6. It means that the number of carbon atom should be equal to 6, and number of hydrogen should be equal to 12. And it should be the symmetrical one. Butene cannot be the correct option. 2,3-dimethyl butene, total 6 carbons are there. Yes, it may be. This is butene, and here is one methyl group. There is another methyl group. If I'm going to break it down, if I'm going to oxidize this molecule, there will be the formation of this one component, but this is not a carboxylic acid. Same is the case, this component will be formed, that is not the carboxylic acid. They both are basically ketone. So again, that is incorrect option. There are two options left behind. They both are having Hex3ene, Hex2ene. They both are having same C6H12 formula. But as I told you, the hexene must be symmetrical, so it can make same type of carboxylic acid. So Hex3ene, that is Hex3ene. This is Hex3ene. Upon oxidation, both side will change into propanoic acid. Both side will be changed into propanoic acid. So it is confirmed that D is the correct option. Question number 40. The last question. Oh, this is about IR spectroscopy. Compound X react with acidified potassium dichromate to form compound Y. So once again, a compound X that is going to react with an oxidizing agent. Now it has been oxidized to a Y, and IR spectrum of the compound Y is over here. This is the spectrum of Y, compound Y, that has been oxidized. And in this spectrum, there are major peaks. Those are lying over here, over here, over here. And this is the huge indication of OH group of carboxylic acid. So OH group of carboxylic acid is present over here. So compound X is a primary alcohol that has been oxidized into carboxylic acid, and so on. That is the indication of C double bond O and C single bond O. So initially it was an alcohol, and especially it was a primary alcohol. Now come towards the option, and here are the options. what is the identity of the compound X? Once again, as I told you, this is the huge indication of carboxylic acid, this broad peak, very broad peak, and that is present at 3000 over here. OH of the carboxylic acid is present around 3000 and it's a very broad peak. OH of the hydroxyamine alcohol that may also be present in this region, but that is beyond than that of 3000. It may be 3200 to 3600. So it is confirmed that it's a carboxylic acid. And which one compound has been oxidized? Obviously, any primary alcohol has been oxidized. So which one is the primary alcohol? This is not alcohol. This is not alcohol. This is alcohol and this is alcohol. 1-ol is the primary alcohol. 2-ol is a secondary alcohol. So A is the correct option. That's all about these main difficult questions. Thank you very much. Please subscribe my channel, hit the bell icon and share it with your friends. Thank you. Thank you very much. Have a nice day.